Hi everyone, in this video I detail the topic isomerization. Isomerism, the compounds having the same molecular formula but different physical and chemical properties are called isomers. The phenomenon is called isomerism. The term diisomerism is proposed by Berzelius in 1827. Example, the glucose molecule, their chemical formula is C6H12O6. They have same molecular formula but different structural formula. Isomerism is the property of all compounds having asymmetric carbon atom. Next is type of isomerism. Mainly two type of isomerism is occurred: structural isomerism and stereoisomerism. First is structural isomerism. When the different compounds having the same molecular formula possess different structure, the phenomenon is called structural isomerism. It arises from the difference in the arrangement of atoms within the molecule. Structural isomers have the same molecular formula but different structures. Based on the linking of atom, there are mainly three types of structural isomerism. First, chain isomerism. Next is position isomerism. Third is functional isomerism. Next is chain isomerism. Isomers differing in the structure of carbon chain are called chain isomers or skeletal isomers, and the phenomenon is called chain isomerism. Example, butane C4H10. They have same molecular formula, different in the structure of carbon chain. Second one is position isomerism. The isomers differ in the position occupied by a particular atom or a substituent group in the carbon chain. This phenomenon is called position isomerism. Example, chloropropyl C3H7Cl. Last one is functional isomerism. Isomerism exhibited by compounds differing in functional group is called functional isomerism. Compound exhibit this type of isomerism is called functional isomers. Example, propanaldehyde and acetone. Second type of isomerism is the stereoisomerism. It is a phenomenon where different compounds having the same molecular formula differ in relative arrangement of atom in space with the molecule, and these compounds are called stereoisomers. Stereoisomerism is mainly two types: geometrical isomerism and optical isomerism. First is geometrical isomerism, where the different compound with the same molecular and structural formula different in spatial arrangement of the groups around the double bond is called geometrical isomers. This phenomenon is considered as geometrical isomerism. The isomers which have similar group on the same side of the double bond is called cis isomer. The isomer which has similar group on the opposite side of the double bond is called trans isomers. So this type of isomerism is also called cis trans isomerism. Example, malic acid and fumaric acid. Next type of isomerism is the optical isomerism. It is a phenomenon where different compounds with the same molecular formula, physical and chemical properties exhibit different optical activity. This type of isomerism is called optical isomerism. Next is, what is optical activity? When a beam of plane polarized light passes through the solution of an optical isomer, the plane polarized light is found to rotate to the left or right in equal number of degrees. It commonly occurs in carbohydrate. It contains one or more chiral or asymmetrical carbon atom. One member of isomer will rotate a plane polarized light in clockwise direction to the right. This rotation is called dextra rotation. It expressed as positive sign and the compound is called D form. Rotation is anti-clockwise to the left of the known as levo-rotation. It expressed as the sign. The compound is called L form. Next is enantiomer. Stereoisomers that are mirror images of each other is called enantiomers. Next is epimer. Epimers are diastereoisomers or diastereomers that differ in stereo centers. Diastereomers are not mirror images. One chiral atom causes that compound to have two possible structures which are not superimposable. Example, D-glucose and D-mannose is the epimers. Next is anomers. Anomers are cyclic monosaccharides or glycosides that are epimers. They are different from each other in the carbon first atom if they are allowed or in the configuration at C2 in the ketosis. Example, alpha D glucopyranose and beta D glucopyranose. Next type of mechanism is the mutarotation. Mutarotation is the alteration in the optical rotation of a soluble dye to the charge in the equilibrium of the alpha and beta anomers of glucose upon dissolution in water. Due to the mechanism of ring chain tautomerism, the alpha and beta develop gradually, interconverting until a state of equilibrium is formed. The sugar molecule D-glucose consists of two common isomers in the cyclic of alpha and anomers and beta anomers. In water, the molecule can unmask into straight chain the linear pattern. The phenomenon first came in the being in 1846 by French chemist Augustin Pierre d'Abrunafo. Occurrence of mutation. Mutarotation. Mutarotation is a repercussion of ring chain tautomerism. This implies that even if you begin with a 100% pure sample of either the alpha or beta anomer, once it has been solvated in water, it can be in equilibrium through the linear pattern to the other anomer. Thank you.